AsapMath.
Hello everyone, in this video we are going to talk about divisibility rules of numbers between 2 and 20. For easiness, we will group the numbers into different sets. Set 1 consists of numbers 2, 4, 8 and 16. This set exhibits a similarity. All numbers are powers of 2. Moving on to first set. First number is number 2. If the last digit of a number is divisible by 2, then the whole number is divisible by 2. Let's consider a few examples. Here, last digit is considered. 2 is multiple of 2, so 32 is divisible by 2. Moving on to next number. If the last two digits of any number is divisible by 4, then the whole number is divisible by 4. We will consider few examples. Here last two digits are considered. 28 is multiple of 4, so whole number is divisible by 4. "50 is not a multiple of 4, so we can conclude that whole number is not divisible by 4. Next number of this set is number 8. If the last three digits of any number is divisible by 8, then the whole number is divisible by 8. Here we have to consider the last three digits. We want to check whether it is a multiple of 8. To make it clear to you, we will use the long division. The result shows that it is a multiple of 8, so we can decide the whole number is divisible by 8. We will consider another example. Last number is 16. If the last four digits of any number is divisible by 16, then the whole number is divisible by 16. Here we have to consider the last four digits. We want to check whether it is a multiple of 16. If it is a multiple of 16, then whole number is divisible by 16. As it is little bit difficult, we will use the long division to analyze this. It shows that it is a multiple of 16. So, whole number is divisible by 16. Let's go to the set 2. It consists of 5 and 10. Number 5. If the last digit of any number is either 0 or 5, then the whole number is divisible by 5. We'll see a few examples. This is very easy to check whether the last digit either 0 or 5. Moving on to next number. Number 10. If the last digit of any number is 0, then the whole number is divisible by 10. We will consider few examples. Third set, consider of 3 and 9. If the last digit sum of a number is divisible by 3, then the whole number is divisible by 3. Addition of every digit is taken. Now we have to check whether this is divisible by 3. So it seems okay. Digit sum is not divisible by 3. So whole number is not divisible by 3. Next number is number 9. If the last digit sum of a number is divisible by 9, then the whole number is divisible by 9. Again, the addition of every digit is taken. It is equal to 18, so it is divisible by 9. Digit sum 24 is not divisible by 9. So whole number is not divisible by 9. Set 4 consists of 6, 12, 14, 15, 18 and 20. First, we will consider number 12 to build up a logic of this. In this method, we have to find the factors of 12 without common prime factors. Here, 3 and 4 don't have common prime factors. So we can conclude that if number is divisible by 3 and 4 both, then number is divisible by 12. We will consider few examples. 60 is divisible by 3 and it is also divisible by 4. So we can conclude that it is divisible by 12. 450 is divisible by 3. But it is not divisible by 4. So it is not divisible by 12. Now we are moving back to 6. If a number is divisible by 2 and 3, then the number is divisible by 6. Consider few examples. 36 is divisible by 2 and it is also divisible by 3. So it is divisible by 6. More examples are listed. Next number is number 14. Here factors to be considered are 2 and 7. So if number is divisible by 2 and 7 both, then number is divisible by 14. But we didn't discuss yet how to find the divisibility of 7. Let's consider that later. We'll consider few examples. 70 is divisible by 2 and it is divisible by 7 also. So 70 is divisible by 14. This is divisible by 2, but this is not divisible by 7. So 166 is not divisible by 14. Moving on to 15. Here factors to be considered are 5 and 3. So if a number is divisible by 3 and 5 both, then it is divisible by 15. It is divisible by 5 and it is divisible by 3. And 90 is divisible by 15. It is not divisible by 3. So 770 is not divisible by 15. Last number of this set is 18. Here the factors to be considered are 9 and 2 because they don't have a common prime factor. If a number is divisible by 9 and 2 both, then the number is divisible by 18. Ninety is divisible by 9 and it is also divisible by 2. So it is divisible by 18. This is divisible by 9 and it is not divisible by 2. So 279 is not divisible by 18. Set 5 consists of 7, 13, 17 and 19. Here last digit of number is multiplied by a number and the product is either subtract or added to the truncated number. So most important things to be identified are identification of number used to multiply and whether addition or subtraction. First we'll go to the number 7. Subtract 2 times the last digit from the remaining truncated number. Repeat the same step as necessary. If the result is divisible by 7, the original number is also divisible by 7. Here are some examples. Here last digit is 7. So it is multiplied by 2. Answer is 14. It is subtracted from the truncated number. So, result is 0. 147 is divisible by 7. We will consider another example. Here, last digit is number 1. It is multiplied by 2. Answer is 2. It is subtracted from the remaining number. So, answer is 693. Then the process is again repeated. Now the last number is number 3. It is multiplied by 2. Answer is 6. When 6 is subtracted, the answer is 63. It is divisible by 7. Then the whole number is divisible by 7. Let's go to the number 13. Here add 4 times the last digit to the remaining truncated number. Repeat the same step as necessary. If the result is divisible by 13, the original number is also divisible by 13. Last digit is 5. It is multiplied by 4. Answer is 20. It is added to the remaining number. Then the answer is 39. It is divisible by 13. So, whole number is divisible by 13. Now we'll consider more examples. Last digit is 2 and the process is repeated. "39 is divisible by 13. So the whole number is divisible by 13. Move to number 17. Subtract 5 times the last digit from the remaining truncated number. Repeat the same step as necessary. If the result is divisible by 17, the original number is also divisible by 17. Last digit is 5. 5 is multiplied by 5. Answer is 25. Then subtract it from the remaining number. Answer is 17. So the original number is divisible by 17. Another example is listed here. Last number is 19. Add 2 times the last digit to the remaining truncated number. Repeat the same step as necessary. If the result is divisible by 19, the original number is also divisible by 19. We will consider few examples to understand the concept. Here, last digit is 2 and it is multiplied by 2. Then answer is 4. It is added to the remaining number. Answer is 19. So it is divisible by 19. Then whole number is divisible by 19. Let's go to another example. Last set consists of number 11. A number is divisible by 11 if the difference of sum of digits at odd places and sum of digits at even places is divisible by 11. Here we need to identify odd places and even places. Sum of even positions are taken. It is 8. Sum of odd positions are taken. It is also 8. Now we have to take the difference. It is 0. This is the multiple of 11. So, whole number is divisible by 11. Moving on to another example. Sum of even positions. It is equal to 10. Sum of odd positions. It is equal to 21. Now the difference of two sums are taken. So we can conclude that whole number is divisible by 11. This video is a bit long video. Here we discussed easy tips to identify whether any given number is divisible by numbers between 2 to 20. Practice the methods discussed in the video and then you can amaze your friends. Hello guys, welcome back to our channel. In this video, we are going to discuss about quick simplification methods for expressions within a square root. Can you solve followings with one step? Oh, it seems a bit difficult. Moving on to first example. To understand the concept, we will describe this with more steps. Expansion of x plus y squared takes the form of x squared plus 2xy plus y squared. In our example, we have given the expanded format and we have to write it as a complete square. So here we can take x squared plus y squared equal to 6 and 2xy equal to 2 square root 5. Here we have two solutions, but the answer would be same on both occasions. We can replace expression 6 plus 2 square root 5 with complete square of 1 plus square root 5. With simplification, final answer would be 1 plus square root 5. There are few important facts to be considered. These two criteria are very much important for next problems. After understanding the concept behind this simplification, let us see how can we quickly solve example 1 with one step. Common format of answer is provided at the right top corner. The answer is straightforward for this example. Now let us see how can we obtain the answer for second example quickly. In this example, there are two possible set of answers for A and B. Now we have to do a little mind calculation to get the correct answer. We learned earlier that a squared plus b squared c should be equal to the natural number within the expression. So here it should be equal to 7. Correct answer is 2 plus square root 3. Now we can do the example 3 using the above steps. Here also, there are two possible set of answers for A and B. We have to do the mind calculation to get the correct answer. Answer is 1 plus 3 square root 2. Now we can work out the example 4 easily. Did you recognize any similarities between example 3 and 4? If we use the other set in example 3, that would be the answer for example 4. Now you can try the following problems. Hello everyone. Today's video we are going to discuss how to obtain the square root of any number within few seconds. Finding square root can be discussed under 4 cases. Case 1. Square root of a perfect square number. Perfect squares are numbers such as 100, 400 and 1225. We can use this method to find square root of any perfect square number. Case 2. Square root of any integer approximately. Example, numbers such as 20 and 45. In this method, we get approximate answers. Case 3. Square root of any integer exactly. In this method, exact answer is calculated and this is a more complex method. Case 4. Square root of any decimal number exactly. This method is similar to case 3. In this video, we will learn about case 1, that is how to find the square root of any perfect square number. Other cases will be discussed in another video. There are few basic things we should know to calculate the square root of a perfect square number. This can be presented as notes. Under note 1, we are going to learn about square of numbers ending with 0. 10 square equal 100. 20 square equal 400. Now I think pattern is almost clear. Take the square of non-zero digits and then put 2 zeros at the end. When taking 30 square, take the square of 3 and then put 2 zeros at the end. 30 square equal 900. Likewise, we can complete the pattern. Under note 2, we are going to learn about square of numbers ending with 5. We have discussed this in a separate video. Anyhow, if we summarize the method, if we want to take the square of 15, first we write 25 and then take 1 and multiply it with immediate integer after that. It will be 2. So answer is 225. Likewise, in all other cases, we can write 25 as last 2 digits. Now we want to find the numbers that are coming to the boxes. What we have to do is take the remaining numbers excluding 5 and then multiply it by immediate integer after that and fill the boxes with the answer. Number excluding 5 is 3. Next integer is 4. Multiply 3 by 4. Put answer in the box. Likewise, we can complete the rest. Note 3. Now you must be wondering we are learning a different thing. Not to take the square root of a perfect square, we must know these concepts. Here also we are going to learn a something we already aware. 1 square equal 1. Now we are going to check the behavior of last digits when we take square. If we just neglect 10 square, we can see a relationship in last digits. 1 square and 9 square will give 1 at the end. 2 square and 8 square will give 4 at the end. 3 square and 7 square will give 9 at the end. 4 square and 6 square will give 6 at the end. So from this we can learn that if number is a perfect square, then the last digit should be either 0, 1, 4, 5, 6 or 9. We are almost done. Now we can find the square root of any perfect square. Let's consider a few examples. Square root of 729. Take number 729. Now remind the note 1 and identify which numbers 729 fall between. 729 is greater than 400 and less than 900. So square root of 729 is a number between 20 and 30. To go for a more close approximation, now take the square of 25. Just remind the note 2. Square of 25 is 625. As our number is 729, now we can conclude that answer falls between 25 and 30. Possible answers are 26, 27, 28 and 29. Reminder note 3. 3 square and 7 square will give 9 as last digit. So only possible answer here is 27. We can cross-check the answer taking the square of 27. Moving on to another example. Square root of 1849. Take the number 1849. Now remind the note 1 and identify which numbers 1849 fall between. 1849 is greater than 1600 and less than 2500. So, square root of 1849 is a number between 40 and 50. To go for a more close approximation, now take the square of 45. Just remind the note 2. Square of 45 is 2025. As our number is 1849, now we can conclude that answer falls between 40 and 45. Possible answers are 41, 42, 43 and 44. Reminder note 3. 3 square and 7 square will give 9 as last digit. So, only possible answer here is 43. Moving on to next example. Square root of 4624. Take number 4624. Now remind the note 1 and identify which numbers 4624 fall between. 4624 is greater than 3600 and less than 4900. So, square root of 4624 is a number between 60 and 70. To go for a more closer approximation, now take the square of 65. Just remind the note 2. Square of 65 is 4225. As our number is 4624, now we can conclude that answer falls between 65 and 70. Possible answers are 66, 67, 68 and 69. Reminder note 3. 2 square and 4 square will give 4 as last digit. So only possible answer here is 68. So now you can find the square root of any perfect square number within 3 seconds. We will discuss next 3 cases in another video. Hey, what's going on everyone? I'm Olivia from AsapMath. Today's video we are going to discuss about the factorization of quadratic expressions. A quadratic expression is any mathematical expression whose power or degree is 2. We will discuss few examples to understand the concept of factorization of quadratic expressions. Moving on the example 1. Answer for this question is x minus 3 into x plus 2. Now let us see how to obtain this answer. We have to find two linear expressions where their product is equals to x squared minus x minus 6. First, we should take the multiplication of coefficient of x squared and constant term. Here it is minus 6. Then we should take the coefficient of x term. It is minus 1. Now we have to find two factors of minus 6 such that their addition is equals to minus 1. Minus 3 and plus 2 satisfies both conditions. Now we can fill two linear expressions with these factors. We have found the answer. To verify our answer is correct, we can expand these two expressions. It shows that our answer is correct. Let's consider another example. First, we should take the multiplication of coefficient of x squared and constant term. Here it is minus 96. Then we should take the coefficient of x term. It is plus 4. Now we have to find two factors of minus 96 such that addition of two factors is equals to plus 4. Plus 12 and minus 8 satisfies both conditions. Now we can fill two linear expressions with these factors. To verify our answer is correct, we can expand these two expressions. It shows that our answer is correct. We will consider a different example now. In previous two examples, coefficient of x squared is equals to 1, but here it is equals to 2. So, when writing linear expressions, we can use 2 as coefficient of x in any expression. Here we will put 2 in first expression. Other steps are almost same. First, we should take the multiplication of coefficient of x squared and constant term. It is equals to plus 12. Then we should take the coefficient of x term. It is plus 7. Now we have to find two factors of plus 12 such that addition of two factors is equals to plus 7. Plus 3 and plus 4 satisfies both conditions. Can we directly use these two factors to complete linear expressions? No, we can't. That's because we have already considered the leading coefficient when writing two expressions. Now, what we want to get is plus 3 and plus 4x terms. If we complete first term with plus 3, from that we can get plus 3. Now, to get plus 4 from second expression, we just need only 2 because there is already 2. 2 times 2 will result in 4. Did you get it? We can't directly use two factors because leading coefficient is not equals to 1. We can expand the result to cross-check our answer. If we just go back to the example 2, we have almost followed the same procedure without our intention. But there as coefficient of x squared is 1, it makes no difference. We will consider another example. Here also, leading coefficient is not equals to 1, it is 5. So, when writing linear expression, we can use 5 as coefficient of x in any expression. Here, we will put 5 in first expression. Then, we should follow the same steps. First, we should take the multiplication of coefficient of x squared and constant term. It is equals to plus 10. Then we should take the coefficient of x term, it is minus 7. Now we have to find two factors of plus 10 such that addition of two factors is equals to minus 7. Minus 2 and minus 5 satisfies both conditions. Now we know that we can't directly use these two factors to complete two expressions. Now what we want to get is minus 2 and minus 5 x terms. If we complete the first expression with minus 2, from that we can get minus 2. Now to get minus 5 from second expression, we just need only minus 1 because there is already 5. 5 times minus 1 will result in minus 5. What if someone complete the first expression with minus 5? Yeah, we can do that also. If we used minus 5 to complete first expression, then now we have to form minus 2 from the rest. If we are to make minus 2 from the second expression, we should complete it with minus 2 over 5 such that multiplication of 5 and minus 2 over 5 is equals to minus 2. Just expand this to check our answer. Moving on to example 5. We can repeat the above discussed steps. Two relevant factors that satisfied conditions are minus 4 and plus 5. Now, what we want to get is minus 4 and plus 5 x terms. If we complete second expression with minus 1, from that we can get minus 4. Now, to get plus 5, we can complete the first expression with plus 5. Here also, one can complete the first expression with minus 4. Then, from second expression, we have to get plus 5. As already 4 is there, we have to complete it with 5 over 4. Both give the same answer, but you can see that first method is much easier. So far, when factorizing, we use the leading coefficient only in one expression. We also can factorize and use it in both expressions. Here as leading coefficient is 4, we can factorize it and use it in both linear expressions. So now, completing the expressions, we must be careful enough to complete them such that their products are equals to minus 4 and plus 5. Let's consider another example. This can be factorized into 3 different ways. From the 3 different ways, one method is much easy and other are little bit difficult. So we should know which method to be selected. Possible 3 methods are shown on right top corner. We can identify 2 factors by following the previously discussed steps. Two factors are 18 and 2. Now we already know that we want to get 18 and 2 near x terms. So, if we choose first method, it is difficult to get 18 or 2. We must multiply 12 by a fraction to get 18 or 2. So, let's move to second method. Here also difficult to get 18 or 2 because again we need to multiply 4 by a decimal number to get 18 or 2. Only left option is third method. Yeah, it is feasible because we can get 18 by multiplying 6 by 3 and 2 by multiplying 2 by 1. So, third method is the easiest way. After figuring out 3 possible ways, we can get coefficient of linear expressions as 12 and 1, 4 and 3, 6 and 2. From these sets, we have to get 18 and 2. So, it is pretty easy. We have to select set 3 because 6 times 3 is 18 and 2 times 1 is 2. Try to figure out this example. There are 4 ways to write linear expressions. Their coefficients would be 36 and 1, 18 and 2, 6 and 6, 9 and 4. Now we want to get minus 9 and plus 4 from this set. So we have to select last set because 9 into minus 1 will give us minus 9 and 4 into 1 would give us 4. So this method is much easier. In this video, we have discussed more easy ways to factorize quadratic expressions. These expressions can be converted into quadratic expressions and factorizing can be done as we discussed. We will prepare a video covering these areas. Welcome back, Masters. Today we are bringing to you another math game. Enjoy this and don't forget to share. Here what you have to do is make 6 with given 3 identical numbers and you are allowed only to use math symbols. And writing of digits is not allowed. First try with yourselves and then proceed with video to cross-check your workings. Starting from the first row. We have 3 zeros and have to obtain the answer as 6. This is actually a bit hard. How to convert 0 to a number with value? Just think for a bit. In one of previous video, we have discussed the factorial 0 is equal to 1. You can use that concept here. Add factorial mark at end of each zeros and then take summation. It will result in 3. And then take factorial of 3, it will give answer 6. This is pretty straightforward. Just add plus mark and then take factorial of 3, it will give you the answer. More complex method for this would be 2 plus 2 over 2 and then take in factorial of that. Here there are several methods. We will start with the easiest method. We can get 3 multiplied by 3 minus 3 equal to 6. Another method would be square root of 3 into 3 plus 3. We also can use 3 factorial plus 3 minus 3. This is also equal to 6. 3 factorial divided by 3 minus 3 factorial also gives 6. In this set, we have to get 6 from 3 fourths. One method would be square root 4 plus square root 4 plus square root 4. We also can use take square root twice from the product of 4 and 4 and then add 4. It will give 6. Square root of 4 plus 4 over 4 and take whole thing and then take factorial. Also we can use square root of 4 plus square root 4 over square root 4 and take factorial of whole thing. Another method would be 4 minus 4 over 4 and then take in factorial. 4 minus square root 4 over square root 4 and take in factorial of whole thing. Last method would be 4 plus 4 minus square root 4. We have discussed many methods. Hope you could figure out at least one method. This is also very much straightforward. 5 over 5 plus 5 will give answer 6. In here we can use 6 minus 6 plus 6 equal to 6 or 6 into 6 and divide the product by 6. This is also very easy. 7 minus 7 over 7 result in answer 6. One method is to take square root twice from 8 plus 8 and then subtract the whole thing from 8. Or take square root of 8 plus 8 over 8 and then take factorial of whole thing. Also we can use take square root of 8 plus 8 and then take factorial of that and then divide it by 8 and then take factorial of whole thing. This also have several methods. Square root 9 into square root 9 minus square root 9 is equal to 6. Take square root twice from the product of 9 into 9 and then add square root 9. Factorial of square root 9 plus square root 9 minus square root 9 is equal to 6. Factorial of square root 9 into square root 9 and divide the whole thing by square root 9. Few more methods are listed below. Take square root of 10 minus 10 over 10 and then take factorial of whole thing. Answer is 6. Here there are another two methods. If you have figured any different methods, please leave a comment.
Thanks for watching. If you like this, make sure to subscribe for more.